Hey guys, welcome back to Business Statistics. This is going to be the one video for Module 9. And I think you are going to be excited or happy or relieved or something like that. Because I am going to be doing one video for Module 9 and no more. And when I say no more, I mean no videos for Module 10 and no videos for Module 11. What I'll do is I'll put out the supplementary videos, which are just basically videos that I've done in the past for past classes covering some of the topics. But the reason that I'm doing this is because you're not being tested on your problem-solving skills with the concepts from 10 and 11. Okay, so in years past, what we've done is in the last test of the year prior to the final, we've put the Module 10 content, which is called ANOVA, Analysis of Variance, and the Module 11 content, which is chi-squares modeling. And actually this, what we're covering now, which is 2-sample, we've put that all on like a third exam. And this semester we decided that we weren't going to test specifically over the problem solving of those last couple of modules. So what I'm doing today is I'm going to be covering just a couple of problems from Module 9, okay? And the only reason we're going to be covering those problems from Module 9 is that you guys are fully apprised of how you should be thinking about, I guess, from a problem-solving stance, your projects. Because, like, I think it's Appendix C, the last thing that you guys have to do in that project is 2-sample hypothesis testing. Okay, so the idea is I'm putting these videos out so that you guys have the tools that you need to do the 2-sample hypothesis testing. But then other than that, I'm not going to make videos for 10 or 11 because all I'm going to have you learn is the concepts. You're probably thinking, wait, but we have to do a quiz on that. No, you don't. So that's another thing that you can see in the announcement in Brightspace is that you do not have to do a quiz on 9, 10, or 11. If you've already done a quiz on 9, I think that's just a couple of you. I'm going to give you a little bit of extra credit for that. But other than that, please do not, I'll take it off there so you guys can't even take the quiz. But you won't be doing a quiz for 9, 10, or 11. You'll just have to do the homeworks, okay, which you can do with just the slides. And if you have spent, like, say, more than an hour on the homework, then you can just be done with it. Basically, what I want you to have is I want you to have a topical knowledge of 9, 10, and 11 such that you can form logical opinions, logical conclusions, such that you can understand it, okay? Not that you have to be able to crunch numbers with the formulas, but I want you to understand the concepts of it. And yeah, other than that, the reason why I'm doing this is we got 2 weeks left in the semester. The final isn't going to test on your problem solving for 10 and 11. And honestly, I just want you guys to focus on your project. I think that that's the most transferable piece of this whole course. It's collaboration with partners, working together. It's problem solving. It's taking a complex topic, something that is hard to understand, breaking it down, using the tools that we've already acquired, that we've already used problem solving on. So I want you to spend time on that. Okay, so another thing that I have addressed in the announcement is that what happens to these quizzes? Well, these quizzes you're going to get full credit for. So no worries, okay? So the quizzes for 9, 10, and 11, you get full credit for them. You don't even have to take them, okay? So that's going to factor into your grade. That's that. And again, this is so that you guys can focus on putting out a good product for this project, okay? So what I want you to do is, so I'm going to put a end date for all of these homeworks kind of deep into the semester. I don't want you to wait to the last minute to do those. But obviously that's going to be on your schedule. And so, the slides are out. And that's that. But yeah, again, this is to alleviate time for you. I know you guys have been working hard this semester. I know that there's been a lot of work in this class. I appreciate you guys being patient with kind of some of the changes that we've had to go through with the class, with the write-ups and all that stuff. And I get it. It's an online class, and this is a tough one to take online. So I wanted to alleviate a little bit of the pressure from you guys, allow you to kind of communicate with your groups, allow you to focus on that in order to get things done. So what I want you to do is over the next, I guess it's just 2 weeks now, I want you to communicate with me as much as you need to. Okay, and that means do not wait to the last minute. Please ask me any questions you have. I'll give you answers as I see fit, right? So what I'm going to do is I'm going to answer the question as best as possible. And if I think maybe you're asking for too much or whatever, I'll answer it as much as possible. And, I'll kind of leave you hanging a little bit to go answer some of it on your own as well. So it does not hurt to ask questions. I'm here to help. I want you guys to do well in this class. I want you guys to do well in this project. And again, that's why I'm taking these quizzes off your plate. You still will have the homeworks because I want you to learn about the concepts, and you'll still have the slides to help you through that. And by all means, if you have questions on the material, please, please, please reach out and ask me. Any clarification I'll gladly do. And then another thing, so if anything for like the final, as I think I've mentioned before, the final is going to be mainly multiple choice. Very little problem solving. It's going to be a lot of concepts, and I'll get you a study guide for that in the next week or so. So we still haven't talked about and kind of hammered down what we're doing with the final, but once I know, which should be within the next couple of days, then I'll let you guys know. Okay? So I hope that this is welcome news, and I hope that you guys are excited and maybe feel a little bit of pressure off with not having to do the quizzes. I know those quizzes are tough. So what we're going to do, I'm sorry that you're staring at a formula screen, but I wanted to make some announcements kind of in person as well, just to better describe what I've written on Brightspace. But let's get into it. I'm just going to do 2 examples, really. I'm just going to do the example from 9.1 and the example from 9.2. The other stuff you're not really going to need, at least not for the rest of this course, okay? If there's something that I miss, I'll make an amendment and write it up there. But I think this is all you're going to need. All right, so without any further ado, let's get into it. All right, comparison of 2 population means with known population standard deviations based on independent samples. So this is all code for 2-sample hypothesis tests, okay? And this is the 2-sample hypothesis test for known population standard deviations, right? So the known versus the unknown in Module 8 was kind of our keyword for when we have a known population standard deviation, we're working with Z. When we have an unknown population standard deviation, we don't have sigma, right? That's our population standard deviation, so we have to work with T, right? Because we only have S. We only have our sample standard deviation. So in 9.1, what we're doing is we're saying we think that we have these assumed population standard deviations, and then we're making a 2-sample test based upon that, okay? So the first thing I want to look at here is this expected value of the estimator x bar 1 minus x bar 2. This is just essentially fancy talk for saying, or fancy statistical jargon for saying the expected value of the difference of the 2 means, right? So when we're comparing 2 samples, they each have a sample mean, and then they each have sort of a proposed population mean, okay? And then this whole big formula here shakes out to, well, the expected value of the difference of these when you minus one from the other is just the expected value of one minus the expected value of another. And all that is saying, well, that's just mu1 minus mu2. That's just the population mean for one minus the population mean for the other. And that's just the difference of the two, okay? So then this distribution merits a new, it in and of itself needs a new standard error. Okay, so standard deviation is what we would call sigma, and then when we factor in the sample size to it, usually we're taking like the sigma over like the square root of n, when we factor that in, that's called the standard error. And in this case, we see the formula for our standard error. Okay, and then we march down one more column. It says confidence interval for the difference between two population means. And we just have E equals Z alpha half times the standard error. E just standing for the margin of error, right? So if we were looking at this, let me see if my pen is working today. The pen always seems to be fickle whenever I get into the video. So E would just be X bar. Of course, it is going to be fickle, isn't it? Oh, for goodness sakes. All right, let me scroll back up. Let's try to write here. All right, that's going to be X bar plus or minus this. Oh, well, yeah, that stands as well, but it's going to be X bar plus or minus whatever is in this E. Sorry about that, guys. All right, and then what do we have here? Then there's our test statistic. Z is equal to X bar T minus X bar N. That could just be X bar 1 minus X bar 2. Those letters don't really matter. It's just signifying the first and the second. Okay. So we're going to go ahead and do an example. I think you guys will see this. This might be a little bit easier than kind of all the statistical jargon makes it seem. I'm kind of glad we're not having to cover this section from a problem-solving perspective. I think you guys are probably a little bit burnt out on the calculation, and I feel like we get into, like, it gets really formula-y into this section of the course, and it's kind of nice that we're going to get a little bit of reprieve from that, and you guys are going to kind of just get to do a project where you're really just taking what you've learned and you're applying it. So we're just going to go through this and just kind of get you through it, okay? All right, so looking at number A, so a manufacturer of golf equipment has developed a new golf ball that has been designed to provide extra distance. In a test of driving distance using a mechanical driving device, a sample of golf balls from, it should say the manufacturer, was compared with a sample of golf balls by a competitor. The sample statistics are provided in the table below. Sample 1 looks like it is going to be our new developed golf ball. Sample 2 is that of the competitor. I swear these were not my spelling mistakes, but competitor, well, it's competitor. A, what is the expected difference between the population average distance covered by golf balls developed by the manufacturer and the competitor? And then B, develop a confidence interval at 95% between the two golf balls. Okay, so the easy one is that new formula that we learned to talk about the expected the difference in expected values, right? So the expected value of the difference is just the difference in the expected values, or the difference in the mu's. So we walk down here, so the difference in the expected value, so we're going to do A, the difference in the expected value. What is the expected value? Also, the expected value of x sub 1 is 275. And the expected value of x sub 2 is 258. Okay, and so then the expected value of their difference, gosh, this pen is driving me nuts again today. I know, guys, I will get it fixed at some point in my life. It's just the difference between the two, okay? Just 175 minus 258. So that's the expected value of the difference. Very simple, right? Just one minus the other. All right. Then the next thing is, what is the confidence interval? All right, so the expected value of the confidence interval is just going to be our expected value of the difference plus or minus some z alpha half, some critical value, times that standard error. Okay, so that's going to be sigma 1 squared over n1 plus sigma 2 squared over n2. Okay, so, and then that's just going to be, we know that this is 17. This means plus or minus. If we're looking for a 95% confidence interval, this is one of those ones that we've memorized. So that's going to be 1.96 for our 95% confidence interval. And then we just go up for our information. So our sigma 1 is 15, our sigma 2 is 20. And then, so that's going to be 15 squared over our n1, which is 120, plus 20 squared over our n2, which is 80. And then this is all going to shake out to be 1.96 times 6.87, square root of 6.875, and then ultimately $11.86 and 22.14. Okay, so that's that. So it's just taking our, so the same old kind of z alpha half, like those memorized values that we've had for the 95% confidence interval, taking that and then using our new formula for standard error. Okay, so this was our confidence thing, our z alpha half times our standard error, and that's just going to be our mean plus or minus that, so our x bar, so our expected value of the difference. So that is that, ladies and gentlemen, for 9.1. So that's just finding the expected value of the difference and finding a confidence interval for that. And I don't know why this is doing that, but this next thing is just going to be introducing the similar t distribution, and we're going to cover a hypothesis for that. So it introduces this concept of pooled variance. So I'm not going to explain to you really what the pooled variance is. It's just saying that when we assume equal variances for populations, and we have two different sample variances, the way that we pool them together and the way that we combine them is by using this formula here. The pooled variance is equal to the degrees of freedom of the first variable times the variance of the variable plus the degrees of freedom of the second times the variance of the second, all over the degrees of freedom of the whole thing, which is n1 plus n2 minus 2. Okay. We have a very similar formula for the confidence interval and a very similar t statistic or calculation statistic formula. Okay. And again, all these formulas and more examples of this can be found on the slides, but we're just going to be brief here because you're not really being quizzed on this. Like, I just want you to have a knowledge base such that like you can kind of guide yourself through completing the project and whatnot. Okay. Okay, so example 8, Clearwater National Bank is conducting a study designed to identify differences between checking account practices by customers at 2 of its branch banks. A simple random sample of 28 checking accounts is selected from the Cherry Grove branch and an independent simple random sample of 22 checking accounts is selected from the Beachmont branch. The variances of the two populations of balances at the two bank branches are assumed to be equal. The current checking account balance is recorded for each of the checking accounts. A summary of the account balances follows. Okay, so this is a similar table that we had last time, right? And it looks like in A, it's asking us to develop a 95% confidence interval to estimate the difference between the mean checking account balance maintained by the population of Cherry Grove customers and the population of Beachmont customers. Okay, so 95% confidence interval. And then B, test the hypothesis at a 5% level of significance that the average balance of Cherry Grove customers is higher than that of Beachmont customers. So you're going to see that this hypothesis test is just going to be the exact same sort of thing that we have been that we've done now for all of 8. Okay, it's the same 7-step process, but we'll go through and we'll run the confidence interval, and then we'll do both. Okay, we will do both. All right. So the confidence interval is going to be similar to what we did last time, except the first thing that we're going to have to do is we're going to have to calculate this pooled variance. Okay, this SP squared, which the formula was just N1 minus 1, so it's the degrees of freedom for the first variable times the sample variance for the first variable, and then the degrees of freedom of the second variable times the variance of the second variable, all over the degrees of freedom for the whole thing. So N1 minus 1 plus N2 minus 1, which shakes out to be N1 plus N2 minus 2. All right, so we go ahead and we do that. Here we go. Let me scroll up. Go ahead and we do that. This you can already see why we don't really want to handle much of this semester, just because there is just a slew of calculation, or is calculation the right term? Just number crunching, just sheer number crunching. 27 150 squared plus 21 and 125 squared, all over 28 plus 22 minus 2. And I am not going to work that out, but other than to say that this is equal to 19,492.1875. Okay, so that is that. Okay, so now we're going to be looking at what is our confidence interval. So our confidence interval is going to be the expected value of the difference. So expected value of the difference plus or minus some t alpha half, comma, the degrees of freedom of the whole thing, okay, times this thing. Again, this formula is in the slides. I think it's above here as well. So that's that. So first things first is, what is this term? Well, this term is just going to be the one mean minus the other mean. All right, so that is 1025 minus 910, so that's going to be 115, plus or minus a t alpha half. So we're going to be, this is going to be like the t of 0.025 comma 48. 48 is just the degrees of freedom of the whole thing, right? So sample size is 28 plus 22 is 50 minus 2 is 48. So this t alpha half number, or this t number, is going to end up being 2.011. I'm not going to show you how to do that. You guys know how to use that t table by now. If you don't, I guess if you have questions, you can look that up on your own. You can check out the videos from Module 8 where we learned about the t-table. But you should be able to do that by now. Obviously, you were tested on it last test. Okay, and then times the square root of 19,492 over 28 plus 19,492 over 22. And this whole thing is ultimately going to shake out to, and like I said, I'm just not gonna, we don't have enough time in the video for me to just like run through all of the itty bitty calculation, but it's going to be 115 plus or minus 79.99. Okay, so ultimately it shakes out to 35.01 comma 194.99. So that is the confidence interval portion of this whole thing. Okay, and let me clear some space here. Okay, and then let's do the hypothesis test on this page. So they want to know, test the hypothesis at 5% that the average balance of Cherry Grove customers is higher than that of Beechmont customers. Okay, so let's do that. So the first thing that we do with the hypothesis test is write out what our hypotheses are. Okay, and so our suspicion, or the thing that we're testing for, is we think this Cherry Grove is going to be higher than Beechmont. So then that goes in our HA, our suspicion. So we're going to call the mu of Cherry Grove just mu C. Say that is greater than the mu of Beechmont. Okay, so then we would just go up to our H naught for our complement of that. So mu C is not greater than, right? So less than or equal to. So that's that. 2, our alpha, because we're looking at 5% level of significance, is 5%. Okay, then 3 is always, well, what is our test statistic? Okay, and because we don't have a sigma, and because we are 2 sample, we're going to be going with the 2 sample t-test. So I'll just say t-test 2 sample. Okay, and our formula, which I believe we can find above, is just, if it's not above, it's certainly in the slides. X1 minus X2, or X bar 1 minus X bar 2, minus the proposed difference in the mu's. All over that standard error term of the pooled variance. Okay, and that's just SP squared over N1 plus SP squared over N2. Okay, and obviously, yeah, let's just scroll up to make sure that that is here somewhere. Yeah, it's right here. Okay, so yeah, that's a better looking version of it. Okay, but that is our test statistic. My writing is awful. All right, and so then we do the same thing that we always do here with our hypothesis test. So we're going to make a curve. Okay, what side is the rejection region on? Well, we look at our HA, and it's pointing to the right. So our rejection region is over here. How big is the rejection region? We look at our alpha, 0.05. Okay, what kind of a test statistic do we have? We have a t test statistic, or a t critical value, I should say. So t crit is going to be equal to the t crit value of 0.05, comma, the degrees of freedom. Okay. Which our degrees of freedom are now what? What are they? 28 plus 22 minus 2. So it's our new degrees of freedom formula for the 2 samples. So it is going to be T of 0.05 and comma 48, which is 1.677. And so then we would just reject if T crit is greater than 1.677. I don't know why I did that, but that's fine. And then 5 is this super long, tedious calculation. Okay, this is what our calculation looks like. This is us just plugging the numbers into the formula. And this is us plugging in our sample means, minusing them with each other, and then minusing off the proposed difference in mu. So whenever you see this mu1 minus mu2, unless we are proposing that there is some actual difference, if we're just comparing them to each other, we just propose that this mu is just, that this difference in mu's is just 0. Okay? And then divided by the square root of 1582.16, that's the square root of sp squared over n1 plus sp squared over n2. I got this just from us doing the last problem. Okay? And I had that in my notes. All right? So whatever, as you're following along, whatever you got for this term from the last problem, you can then use that in here. So we ultimately get a t-calc value of 2.89. Okay, so obviously 2.89 is greater than 1.677, so we reject. So rejecting the null, go back up here to the null, we reject that Cherry Grove is less than Beechmont. Okay, so we say there is enough evidence to suggest, or we do have significant evidence to suggest, that the average balance of Cherry Grove customers is higher than that of the Beechmont customers. Okay, so that's that, guys. That is all I have for you. In fact, that is the last video of new content that I am likely going to do for the rest of the semester. Okay, I may put out a video just talking through some of the concepts prior to the final. I'm not sure about that. Maybe let me know via email if that's something that you'd be interested in. But like I said, the final is more concept based, and I will be getting a study guide out to you guys about that. So don't worry about that. It's going to be very clear the topics that you should study. So that'll be good. But yeah, so this is all the new content. This is all the computation that you'll need. But yeah, like I said, no more quizzes. Just get through those homeworks and work hard with your team on the project. Please don't wait to the last minute. If you guys wait to the last minute on this project, things will not go well. And I don't want to have to deal with that. I know you guys don't. I've met with a number of the teams, so just know that if you're one of the teams I haven't met with, the other students in the class are working on this, and they have now for some time. So I'm really excited about that, and I know some of the teams are doing really good work already. So yeah, guys, thanks so much again, always, for your patience this semester, and hopefully you're learning something. And yeah, all right, please email me. Let me know if you have questions. I'm always here to help. All right, I'll talk to you later.